So I skipped this because I wanted to finish confidence interval stuff before I got back to this. So we just talked about margin of error. So I'm going to write up here again. Margin of error equals our critical value, which is our Z or T. This would be Z times sigma over square root N, or P times S over square root N. So how could I make that margin of error smaller? So just looking at, doesn't matter which equation I use, I can talk about it the same way. What thing can I change to make this whole thing smaller? All right, I need to make my N what to make this answer smaller? Because it's in the denominator. So a larger sample size so I'm doing a study. I want to make sure that I am correct within 2 points. I want to make sure that I'm correct within 5%. I can change my sample size to make sure that I'm correct within a certain amount. What's another thing I can change? So I already talked about N. Where does T come from? Where does T or Z come from? What do I need to be able to find Z? Confidence level. So can I change my confidence level? Yes. So if I want my margin of error to get smaller, what kind of confidence level would I want? N is on the bottom. So as N gets bigger, this whole thing gets smaller. T is not on the bottom, so it works directly. So taking a smaller Z, which comes from a smaller or lower confidence level. Let me say it a different way to make more sense. I am 50% sure that the weather is between 45 and 49, but I'm 100% sure, or 97% sure that it's maybe between like 20 and 60. So my width got bigger as my percent of confidence got bigger. And so think about it that way. So I don't love to talk about this one. I kind of want to write, I can change. It's very easy for me to say, I need to go and sample more people next time to have a better margin of error. I need to change my confidence level for my margin of error. What's the only other thing in that margin of error equation that I haven't talked about? Can I change the standard deviation? Can I change how much a group varies? No. So I don't want you to think about that as like that's something I can do if I build a project. So these are things that I can change. This is technically like if I took a different sample and I'm dealing with S, and my different sample had a smaller standard deviation, that would make my margin of error smaller. I don't really like talking about that because people get confused about that. So these are the two things that I can control. And again, this kind of follows in with that idea that I said yesterday of your quiz is a lot of concept stuff more than just solving. Alright, so the way I asked the question at first is like, I want to make sure that I am correct within 5%. I can now say, how many people do I need to sample to make sure that I'm correct within 5%? So I am starting with my equation, which is margin of error equals what? We just wrote this down, or I just keep talking about this. If I build a z, what does margin of error equal? So basically we're saying I'm setting this. I need to find what this needs to be. Algebra. So I want n by itself. So algebra, what's my next step? How do I get rid of this? How do I get rid of this? I gotta move it over there first. So right now I have square root of n times margin of error, z times sigma. I want this by itself, so what's my next step? I want n by itself, what's my next step? Algebra. Divided by margin of error. So right now I have square root of n equals z times sigma divided by margin of error. My last step is just to do what? Square both sides to get rid of that. And now I'd solve the equation this way, but we need to make sure that our sample size is at least big enough. So really our equation is that n has to be what? Symbol size in between, inequality. If I want to make sure that I want to be correct within 4 points, I need to make sure that my sample size is what inequality? At least whatever I get when I do this. So margin of error can actually be a number. So like if we're doing this is not only but like we're just dealing with something with weight, and I want to make sure that I'm correct within 7 pounds. Then I would set my margin of error to be 7 and solve this to see what my sample size needs to be. So on that same sheet in front of you, my numbers might be different than yours. Does your number 4 say the weights of JLM students? No. Yes or no? No. You have one that says the weights of JLM students is normally distributed? Okay. I only did this with margin of error of z and sigma. But I could also have margin of error set equal to what? I could switch out what instead? Margin of error can be equal to z times sigma over square root n, or it can be equal to what? T times s over square root n. That equation does not apply here. Why? What are we solving for? On the board, what are we solving for? Sample size. So why can I not use T and S? Do I need sample size to find S? Do I need sample size to find T? Yes. So if I'm solving for N, I don't know N. Can I use T in there? No. So you never use T when you're solving for a sample size like this because you can't. So we're always going to put Z there. So number 3 is the heights of JLM students, right? Okay. I'm looking at this problem, and I am just looking really quick. how do I know that I'm not doing a 4-step process? It asks me for something completely different. What wording is telling me that this is asking for something completely different? How large a sample? How large a sample means I'm solving for n. So I'm going to go ahead and write down everything it tells me. So normally distributed. Why is it important that it says normally distributed? So I can use Z. How large a sample, so I'm solving for n. What do you think the within 70.75 inches is? So we want our margin of error to be within that. And what am I missing? So it gives me my confidence level, which is 95, is that what yours is? And what do I use that to find? So I can go back through the process of doing 1 minus 95.95, which is 0.05 divided by 2, look it up. Or I could go a whole lot easier and look where? On the T table at the very bottom where it says infinity. And so a Z for 95% gives me what? So now I'm just setting up my equation, and you can choose to do this either way. Some of you are going to memorize this, especially if you're like, I'm going to mess up algebra on the test or the quiz. I'm just going to go ahead and memorize that, and that's totally fine. I'm going to show you not. So I'm going to go back to where we started. Margin of error equals Z times sigma over square root of n. My margin of error is 0.75. My Z is 1.96. My sigma is 2.5. And square root of n is what I'm solving for. It is a whole lot easier if you never type in a single number until the very, very end. Otherwise, you're going to be typing in rounding, typing in rounding, typing in rounding, and it's going to be a lot of work. So we're going to do the algebra without doing any math here, or doing it like plugging anything in. So going back to the steps we just did, what do I do first? What? Times square root of n, so I get it on both sides. So here cancels out. So right now I have square root of n times 0.75 equals 1.96 times 2.5. Algebraically, what's my next step?
Algebraically, wouldn't you first multiply this or divide?
You'd be moving it twice if you had to do that. Like you can multiply or divide any one thing, but you're going to divide this whole side and this whole side. But I'm eventually going to get n by itself over here, so then I have to move 1.96 back over again. So I mean, technically, yes, you could do it that way. But multiplying from the bottom or dividing from there doesn't matter either way. All right, so then from here I do what? And my last step is square both sides. So n is going to be greater than or equal to 1.96 times 2.5 divided by 0.75, and that whole thing is squared. I want everybody to type that in. You need a calculator, get one. And I'm having you type it in so that you know you're typing it the right way. You get that quiz and you're like, I know the equation. Hey, I need help. I can't type to my calculator. That's why I'm doing this now. And you get what with decimals? What's your whole number part of it? 42 point something, right? What's the first number? I need this many in my sample. Is 42 enough? Even if that is 42.000006, is 42 enough? So my answer is that I need at least what? So you always go up to the next whole number, because if you have a decimal at all, what you have is not enough. So this is how they figure out how many Dale Mandel students they would need to sample in order to be accurate within 3/4 of an inch. It's definitely something they consider when they're doing stuff like voting. They want to make sure they're correct within a certain percent. They need to know how many people they need to sample. All right, once you've done one of those, they're all the same. If it says how large a sample or how many, it's that kind of problem. Go to your worksheet from yesterday. And so I started to talk through this problem. We're going to go ahead and do it all the way through.